Got a year 13. This is just a quick lesson on log laws whilst I'm away. So this is exercise 2C of your textbook. Basically, there are some log laws you need to know, which allow you to solve questions to do with logarithms. So the first one is if you've got log base A and you've got a multiplication in there, log A xy, then that can be expanded out to be log base A x plus log A base y. Okay. Quite often you actually see it as the log x plus log y, and then you've got to change it to the multiplication. But this is the first law that you need to know, and it's multiplication. Multiplication. The next one is very similar. If you've got log base A x over y, then that can be rewritten as log A x minus log a y. Again, going both ways, and this is our division law. Okay, and there's one last main law, which is if you've got, and this is one I mentioned yesterday, log A x to power m, then what you can do is you can bring, well, I suppose it's the power m is only on the x. If there was other things in here, like if it was a quadratic, this law doesn't actually work. But basically, you can bring the m part to the front, so it's m log a x. And that is a multiplication, by the way. It's m times log ax. And this is our power law. Okay? And with these three laws, it allows you to solve a lot of different things to do with logarithms. This power law is actually really important for when we're solving unknown indices / exponents later on. Using the last log law, the power law, there's one more thing that could be considered kind of a log law, but it's just basing off a previous one, which is if you've got log of any base 1 over x, that can be rewritten as minus log ax, because, well, I'll do the full work into log a x to the minus 1, which becomes minus log ax. So log 1 over x is the same as minus log x. Again, we're using any base because theoretically we could use any base and use yesterday's rule of if you've got a to power x equals y, then you've got, that can be rewritten as log ay equals x. But yeah, okay. So combining these things together is kind of what the focus of today is. Pretty much that is it for now. But let's have a look at one of the questions on the worked examples. Oh, sorry. The other thing I should have said is there are proofs of these on page 33. And I'm happy to go through them, but when I'm back in class, not just right now. So if anyone's interested in that proof, I will go through it for you. So then on page 34, there's some worked examples where they just show you, if I've got log base 2, 3, plus log base 2 of 5, if I'm adding those two together, then it's just the same as having log base 2, 15, for 3 times 5. So that's worked example 2.8, so I'm not going to worry about doing that. Whenever you've got a number in front of a log, such as if you've got the third part of that example, which I'll just use as my first example. If you've got 2 log base 2 plus log base 5, there's a base 5 on the first one, base 5, 3. If they're different bases, you can't add them. So let's just quickly say that. If I've got log 2, 4 plus log 5, 3, I can't add... There's nothing I can do here. There's nothing I can do. I could potentially start thinking about the rewritten versions of these somehow. I think there are some rules that you can apply with different bases. But for today, I don't even know if it appears in Cambridge at all, actually. Maybe it will appear in a different lesson. But don't worry about anything like that. Different bases don't... These laws don't apply. Okay? But anyway, 2 log base 5, 2 plus log base 5, 3. In this question, you have to remember BIDMAS, basically. Make sure you deal with the indices stuff first. So because I've got 2 log 2, that's going to become log 2 squared plus log 3, which is the same as having log 4 times 3, which is log base 5, 12. Okay, so deal with your powers before dealing with your multiplication. You should all know that by now. Let's have a look at the one which is worked example 2.9c. So example 2, that is log base 4 64 over p. And it says at the top, given that log base 4 p equals x and log base 4 q equals y, expressed in terms of x and y. So we know log base 4p equals x, so we're going to try and rewrite this in terms of x. Okay, we've got no y term because there's no q involved. So what we can say is that this is the same as log 464 minus log 4 1 over p. Log 464 is the same as 3. If you use what they've done there is they've written it as log 4 cubed and used the log x equals x rule to say that that is just 3. With the other log, they've converted it to p to the minus 1, which means that you end up with log plus log 4p, which is just 3 plus x, it should be. Oh, sorry, that's a mistake. Yeah, because it was because we changed it to minus. In reality, I actually created a plus p minus 1. That was a mistake. Log 4p is what I should have got. Okay, because it's divided by p. To have it still as p minus 1, that would have been if I left it as plus log 4p minus 1. So when we get this, we get minus, which is just minus x. Okay, sorry about that. So yeah, when we split it off at the start, it should have been log 464 minus log 4p. Okay, not p minus 1. So we get 3 minus x. So that's kind of it. Obviously, there's some harder questions if you look in the exercise, but just have a go at exercise 2C. And hopefully I'll be back in tomorrow. Okay, bye.